Programming assignment 3, we were given a number of cities and a list of possible roads to repair. Our assignment was to find the minimum cost of building libraries and roads so that each city either has a library or is connected to a city with a library. The first plan was to create a breadth first search and implement a queue, but we found that a BFS was not the most efficient solution, while BFS was root down, and we wanted to rather find the root of a node. For the final program, we didn't need a full search, while BFS did.
Our function is correct. The first thing we do is check if the price of libraries is the same or possibly even cheaper than the price of roads. If this is indeed the case, there is no point to building any roads, so the total cost would be the price of a library times the number of cities. If this is not the case, we will need to find the number of roads that we need to build. To keep track of the roads we've already decided to build, we'll use an array and set each element's value to its own index because we already know that each city is connected to itself. In this array, the index corresponds to a city and the value is a city it connects to. After finding the number of roads needed, the algorithm finds the number of libraries. The number of libraries is equal to the number of cities whose root is itself. We then just need to multiply the number of libraries needed by the cost and then add it to the number of roads multiplied by the cost of each road. This here is the disjoint function I mentioned earlier. It works by using the find function to check if two cities have the same root. If they do, the function returns false, but if they are not, then they're disjoint, so it would return true. The find function finds the root of a city. It checks if the city's root is itself. If it is, then it will return true. Otherwise, it recursively checks looking at the root of the parent.
So let's go over this algorithm with an example. We start with 5 nodes, each of which can be considered its own tree that make up a forest, as we see on the board right now. And since each node makes up its own tree, that means that it itself is the root, and it is also a parent of itself. So as you see in the array called parent on the bottom right-hand side, 1, 2, 3, 4, and 5, each of these have parents of themselves. Now, here we add in all of the possible roads. So all of these dashed lines represent the possible roads that are given in the top right. So 1, 2, 2, 3, 4, 5, and 1, 3. Now, no actual changes have been made yet. These are just the possible roads, but from here, we can use the algorithm to get the right answer. So in the first, this one right here, 1, 2, we immediately make a road right there connecting 1 and 2. And according to the algorithm, we make the parent of 1 be 2 because the second city listed becomes the parent of the first if the road is created. So now we have 1, 2. Here we go to the next one, 2, 3. And this is also added because if you look, the root of 3 is still itself. So you add this road, and according to the algorithm, once again, the parent of 2 now becomes 3. So right now, the structure looks like the root of 1 is 3, because 1 to 2, 2 to 3, and then 3 to 3. So this is a root. And then 4 is still its own tree, 5 is still its own tree. So this right here is looking good. Now we can go to the next one, 4, 5. We go through the same process. We have 5 and 4 right here. They're both, 4 is a root itself. So we make the road. 4 is now connected to 5. And we have this tree right here where 4's root is 5 and 5 is a root of itself. So this tree is good. And now this last one is the only one. Oh, that's not okay. This last one is the only one that doesn't get added because when you go to 1, 3, you go and you check the root of 1. So 1 has the root, which is 1 to 2, 2 to 3, and 3 to 3. So since 1 is already connected to 3, this is not added at all. So in the end, you make in each connected component, you make 1 city in each, and this will give you the correct answer. It will give you a minimum price, a minimum cost to make the city and road.
One of the issues that we found in the programming was that we had integers for road num and library num, which caused for some test cases the value of int was too small, so it wasn't running properly. And then the second issue we found was that we didn't initialize library num, which was causing the value of libraries to be inaccurate.